Imagine looking up at the night sky and realizing that every star you can see belongs to just one galaxy, the Milky Way. Beyond it lie countless other galaxies scattered across the universe. Some are larger than our own, some are smaller, and some are so distant that their light has been traveling toward us for billions of years. This leads to one of the most fascinating questions humanity has ever asked. Could we one day travel beyond our galaxy? For most of human history, crossing an ocean seemed impossible. Flying across continents sounded like fantasy. Even reaching the moon was once considered beyond our abilities. Yet humanity achieved each of those milestones. But traveling beyond the Milky Way is an entirely different challenge. The scale involved is almost impossible to comprehend. Our galaxy alone is about 100,000 light-years across. It contains hundreds of billions of stars. Yet in the vast universe, the Milky Way is only one galaxy among countless others. The nearest major galaxy to us is Andromeda. It lies approximately 2.5 million light-years away. To understand how far that really is, consider the speed of light. Light travels at nearly 300,000 kilometers every second. It is the fastest speed known in nature. And yet, even light requires 2.5 million years to travel from Andromeda to Earth. That single fact reveals the enormous challenge of intergalactic travel. With today's technology, such a journey is completely impossible. The fastest human-made object ever launched is Voyager 1. It has been traveling through space since 1977. Even after decades of continuous travel, it has only begun to leave our cosmic neighborhood. At its current speed, reaching another galaxy would take far longer than human civilization has existed. Perhaps even longer than humanity itself survives. So what prevents us from traveling faster? The answer lies in the laws of physics. According to Einstein's theory of relativity, accelerating an object requires energy. The faster that object moves, the more energy it needs. As it approaches the speed of light, the required energy increases dramatically. To reach the speed of light itself, an object with mass would require an infinite amount of energy. That is why scientists believe faster than light travel is impossible using conventional methods, at least according to our current understanding of physics. Yet relativity also reveals something extraordinary. Time itself behaves differently at extreme speeds. As a spacecraft approaches the speed of light, time slows down for the travelers on board. This phenomenon is known as time dilation. To observers on Earth, centuries or even thousands of years might pass. But for the travelers, the journey could feel significantly shorter. While this does not solve the problem of distance, it changes how such journeys might be experienced. Scientists have imagined several technologies that could one day bring interstellar and perhaps intergalactic travel closer to reality. One possibility is nuclear fusion propulsion. Fusion powers the sun itself. If humanity can master fusion engines, future spacecraft could travel far faster than anything we possess today. Another concept involves antimatter. When matter and antimatter meet, they release tremendous amounts of energy. In theory, antimatter propulsion could make incredibly fast spacecraft possible. Unfortunately, producing and storing antimatter remains one of the greatest engineering challenges ever faced. Other ideas are even more ambitious. Some scientists have explored the possibility of generation ships. These would be enormous spacecraft carrying entire communities. Generations of people would live and die aboard the vessel while their descendants continued the journey. The travelers who arrived would be separated from the original crew by centuries or even millennia. Then there are the concepts that seem almost like science fiction. Wormholes, warp drives, shortcuts through space-time itself. Certain theories suggest these ideas may not completely violate the laws of physics. However, there is currently no evidence that such technologies can actually be built. Still, scientific progress often begins with ideas that once appeared impossible. What seems unattainable today may become achievable centuries from now. There is another possibility. Perhaps humans will not be the first explorers to leave the galaxy. Advanced artificial intelligence may travel where biological life cannot. Future robotic probes could survive journeys lasting thousands or even millions of years. Machines do not require food, they do not need oxygen, and they are far more resistant to the harsh environment of deep space. They may become humanity's first ambassadors to other galaxies. Meanwhile, the universe itself continues to evolve. The Andromeda Galaxy is slowly moving toward the Milky Way. In billions of years, the two galaxies may eventually merge into a single, larger galaxy. Long after humanity's present era has passed. So, could we one day travel beyond our galaxy? With today's technology, the answer is no. With future technologies, the answer becomes less certain. History has repeatedly shown that humanity has a remarkable ability to achieve what once seemed impossible. From sailing across oceans to landing on the moon, our species has continually expanded its reach. Perhaps one day our descendants will do the same on a cosmic scale. Maybe millions of years from now, travelers will look back toward the Milky Way and see it not as a destination, but as the place where the journey began.